ENCLAPSലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the Enclaps channel. Ring the bell button and open success. It's that easy.
Hi. Today we are going to study about S-block elements. Okay. So when you write the subshell electronic configuration and the last electron enters to the outermost S subshell, then the element belongs to S-block in the periodic table. The group 1 elements, that is the alkali metals, and the group 2 elements, that is the alkaline earth metals, belong to S-block in the periodic table. If you consider the case of S-block elements, if it undergo chemical reaction, then it will donate electrons. As it donates electron, it shows positive oxidation state. Group 1 elements, that is the alkali metals, usually donate 1 electron when it undergo chemical reaction, so it shows +1 oxidation state. And the group 2 elements, that is the alkaline earth metal, usually donate 2 electrons when it undergo chemical reaction. As a result, alkaline earth metal shows +2 oxidation state. The oxides and the hydroxides of the S-block elements are usually basic in nature, and these oxides and the hydroxides of the S-block elements usually react with the acid and results in the formation of salt and water, and it also converts red litmus to blue litmus. These are the main characteristics of the S-block elements. Now we are going to study about how to determine the group number of a S-block element. If you write its subshell electronic configuration, then count the number of electrons in the outermost S subshell and it should be its group number. Now let us consider one example. Look here. Here you can see that one subshell electronic configuration, 1s2, 2s2, 2p6, 3s1. Now we are going to find out the group number of this element. So before going to find out the group number, you have to determine the block. Here if you look at this subshell electronic configuration, you can see that the last electron enters to the S subshell, right? That means this element belongs to S block in the periodic table. So now in order to find the group number of the S block element, you just want to count the number of electrons in the outermost S subshell. Here you can see that the outermost S subshell contains only 1 electron. That means this element belongs to group 1 in the periodic table. Now consider one more example. Look at this electronic configuration, 1s2, 2s2, 2p6, 3s2. Here if you look at this electronic configuration, you can see that the outermost shell containing 2 electrons in the 3s subshell. Okay. So since the outermost subshell is 3s subshell, it belongs to S block in the periodic table. Then how will you find out its group number? Yes, you just want to count the number of electrons in this 3s subshell. It contains only 2 electrons. That means it belongs to group 2 in the periodic table. In a similar way, if you write the subshell electron configuration and if it is a S block element, then you just want to count the number of electrons in the outermost S subshell and it will give you the group number of the S block element. Okay. Now let us do one activity. So look at this table. Here you can see the information regarding 2 elements represented by X and Y. So we need to find out the remaining details and we want to complete this table. Okay. So first we are going to deal with the element X. Here it is given that the element X has oxidation state +1 since its valency is 1. So how can you write the ionic form of this element X? X 1+. Now we have to find out the chemical formula of the oxide of this element X. Since the ionic form of the element X is X1+ and ionic form of the oxygen is O2-, how can you write the chemical formula of the oxide of this X? Yes, X2O. This is actually the chemical formula of the oxide of the element X. Okay. So now let us consider the case of the element Y. So in the case of the Y, it is given that the valency of the Y is 2 and its ionic form is represented as Y2+. So what should be its oxidation state? Yes, 2+. Now we have to find out the chemical formula of the oxide of this element Y. Since we know that the ionic form of the Y is Y2+ and the ionic form of the oxygen is O2-. So how can you write the chemical formula of the oxide of the Y? Yes, YO. So this is the chemical formula of the oxide of the Y. Now we can conclude the important features of the S block elements. Okay. S block elements are metallic nature, Its ionization energy is low. It has low electronegativity. Electron is released during chemical reaction. It forms ionic compounds. Group 1 elements shows high reactivity. Oxides and hydroxides of S block elements are basic in nature. Group 1 elements are largest elements in the corresponding period. Reactivity increases as we move from top to bottom in a group. So these are the important features regarding the S block elements. We will discuss the remaining P, D and F block elements in our next class. See you later.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ എൻക്ലാപ്സ് ദ ലേണിംഗ് ആപ്പ്.